We're solving problem 13 from the 2020 F equals MA exam A. A ballerina with moment of inertia I is quickly twirling with angular velocity omega. In her hand, she has a pen of mass m at a radius r from her axis of rotation. The ballerina releases the pen. Afterward, what happens to the vertical component of the angular momentum of the system consisting of the ballerina and the pen? You may ignore all friction, but not gravity or normal forces. And then we have A, it decreases until the pen hits the floor. B, it increases until the pen hits the floor. C, it stays the same. D, it initially stays the same but decreases after the pen when the pen hits the floor. Or E, it initially stays the same but increases when the pen hits the floor. Here we have a depiction of all the forces acting on the pen, the weight, normal force, and inertia, and omega, how much it's spinning. So we can sum all of the rotational forces and energy to get into one equation. So we get that L is equal to inertia times omega plus R times mv. This equation shows that the forces are only in the vertical direction. The external forces are perpendicular to this, the vertical, so therefore it stays the same because there are no other forces acting on it. Therefore, answer choice C is our answer for this problem.